Have you ever looked at a map of the world and wondered, why do all the volcanoes and earthquakes seem to cluster in the same spots? Well, today we're diving into the biggest, baddest, and most fiery cluster of them all. We're talking about the Ring of Fire.
First off, let's just wrap our heads around the sheer scale of this thing. The Ring of Fire isn't some small little hotspot. Oh no, it's a massive tectonic belt that stretches for a whopping 40,000 kilometers. That's 25,000 miles in this giant horseshoe shape all around the Pacific Ocean. That's a feature of the entire planet.
And its impact, it's just as huge. I mean, the amount of power concentrated here is absolutely mind-boggling. This one belt is responsible for about 90% of the world's earthquakes. Just let that sink in for a second. 9 out of every 10 quakes on Earth happen right here.
And it's not just the shaking, it's the fire too. The Ring of Fire is home to more than 750 active and dormant volcanoes. That's something like 2/3 of all the volcanoes on the planet, all jammed into this one incredible zone.
Okay, so we've got the what and the where down. We've got this massive belt of shaking and erupting, but the real mystery is why? Why is so much of Earth's most dramatic action packed into this one specific area, which scientists call the Circum-Pacific Belt?
Well, the first thing to understand is that this isn't one single solid ring. It's not some neat circle of fire. It's actually the messy and often pretty violent result of something much, much bigger happening just beneath our feet. The constant grinding collision of giant pieces of our planet's crust.
And that right there brings us to the engine that drives this whole show, the theory of plate tectonics. You can basically think of the Ring of Fire as a map. It's a map that shows us exactly where these giant puzzle pieces of Earth's surface are meeting, scraping, and crashing into each other.
And in this cosmic demolition derby, you've got a few main players. The huge Pacific Plate is at the center of it all, pushing against and sliding under other big ones like the North American and South American plates. It's also tangling with plates like the Philippine and Nazca plates. It's like a global traffic jam in super slow motion, and the Ring of Fire is where all the fender benders happen.
So, these plates are constantly crashing into each other. But how does that actually, create a volcano or an earthquake? Well, the answer is a powerful process that happens right at these boundaries. And to get it, we need to talk about one key idea: subduction.
Subduction. That's the magic word. It's pretty straightforward, really. When two tectonic plates collide, one of them has to give. The denser plate, and that's usually the heavier oceanic crust, gets forced to bend and slide underneath the other one, beginning this long, slow-motion dive deep down into the Earth's hot mantle.
Let's just walk through it real quick. Step 1, the plates collide, bam! Step 2, the denser plate starts sinking or subducting. Step 3, as it goes deeper, the insane heat and pressure cause the rock to actually melt, creating magma. And finally, step 4, this new magma is hot and buoyant, so what's it going to do? It rises, it pushes its way up to the surface and eventually erupts, and boom, you've got yourself a volcano.
And here's a cool little detail. Not all subduction is created equal. It turns out the age of the sinking plate makes a big difference. Younger, warmer plates, like the ones off the coast of Chile, are a bit more buoyant, so they sink at a shallow angle. That creates volcanoes right there on the coast. But older, colder plates, like near the Mariana Islands, are much denser. They sink at a super steep angle, and that forms volcanic island chains farther out in the ocean.
Okay, so we've got the science down. Now let's talk about the consequences. Because all of this tectonic diving and melting, well, that's what puts the spectacular and sometimes terrifying fire in the Ring of Fire. You know those classic picture-perfect cone-shaped volcanoes you always imagine? The kind you see on postcards? Well, subduction is a pro at making those. They're called stratovolcanoes, and iconic peaks like Mount St. Helens in the US and Mount Fuji in Japan are perfect examples, born directly from this process. And the power these things can unleash is just staggering. Get this, the 4 biggest volcanic eruptions on the entire planet in the last 11,700 years, every single one of them, happened at a volcano right here, along the Ring of Fire. This place doesn't just do activity, it does extremes.
You know, people have been noticing this pattern for a very long time, even way before we really understood the geology behind it. More than a century ago, back in 1906, a writer named Alexander Livingstone described it perfectly as the Great Ring of Fire which circles round the whole surface of the Pacific Ocean.
And man, was he spot on. To really put its power into perspective, remember that 90% number for earthquakes. Well, the next most active region on Earth, the Alpine Belt, only accounts for about 6%. I mean, it's not even a contest. The Ring of Fire is in a league of its own.
This is also home to the big ones. We're talking about megathrust earthquakes. They are the most powerful type our planet can produce. In fact, the list of the strongest earthquakes ever recorded reads like a greatest hits tour of the Ring of Fire. Chile, Alaska, Japan, Russia, they're all here. All of them are giants, born from subduction.
So here's the really important thing to remember. The Ring of Fire isn't just a place on a map. It's a living, breathing process. It's a dynamic story of a restless planet. And trust me, that story is nowhere near its final chapter.
I mean, these forces have been chugging along for an almost unimaginable amount of time. The version of the Ring of Fire we see today started taking shape over 35 million years ago. And for all that time, it's been building mountains, creating islands, and constantly redrawing the map of our world.
And it is not stopping. Right now, as you're listening to this, the plates are still moving, the rock is still melting, and the world is still being built. The exact same process that created the world we live in is, right now, creating the world of tomorrow. And that leaves us with a pretty incredible question to think about. What's it going to create next?